So, first of all, before we begin, what's the audience like? I want to know something about each and every one of you. Or, how many Android developers do we have? 2. All right. 5, 6, and probably some people that are afraid to mention it.
Well,
Okay.
This guy
all right.
apparently is half of developer. He was like this.
All right, so we are going to obviously talk about Android development because that's what we do, but it's fairly high level and fluffy for the most part. We'll give you a sense of where Android is at and the sort of overall ecosystem.
So Chet's section will be fluffy. I will show you code and demos.
Yes, so we will appeal to both kinds of developers, the ones who code and the ones who pretend to. I am Chet Haase. I'm on the developer relations team. I was doing UI toolkit stuff for many years at Google, and then I recently moved to the group that does outreach at events like this.
And I'm Romain, and I manage the Android toolkit team at Google. So it's the team responsible for the UI toolkit and a suite of libraries called Jetpack that we're going to talk about in a little bit.
All right, so we're going to dive right in. We gave this talk. We went to a conference yesterday in London, DroidCon. And we had an hour, and an hour and 2 minutes later, we still hadn't finished. So we've reduced down some of the stuff that we're going to talk about, and we're going to dive right into focusing on the user. So two of the main things that we've always done on Android have been to focus on what users need to get devices that actually work well for them, and improving the user experience over the years, and what developers need in order to write the applications that the users actually care much more deeply about than they do the core system UI. So we're gonna, well, hang on, we were supposed to hide those slides.
Yeah, partly.
We didn't hide those slides correctly.
So just ignore what you're seeing on
blah, blah,
screen
blah,
right now.
blah, 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 many things.
got
There
that?
we go. All right. So on the user side, I'm going to talk about the user changes that we've been making in recent releases, and then Romain is going to talk about some of the recent developer improvements. But when I talk about user features, we're going to talk about things that we've done that the users really need that affect the developers. So this gets into basically 3 issues that I want to cover. One is battery life. So making sure that the system is using only the battery it requires. So basically cranking back on the amount of stuff that's actually happening on the system to make sure that it's focused on the activities that the users actually care about and want to be happening. Another one is really important, always has been, but it's increasingly important in the last few years, which is privacy. Making sure that applications only have access to the data, the user data, that they should, and that the user has information that they need about who has access to what. Right, making it much more transparent and much more controllable from their point of view to make sure that applications aren't getting access to information that the user doesn't even know about them. And finally, usability. What can we do to actually make behavior on the device more predictable and usable for them in general?
And the reason we're talking about all this, because you'll see there's a common theme to all those problems, is that we are kind of restricting access to some of the features of the Android platform. And, we don't like it. I know a lot of you don't like it either. But when we created Android, we wanted a really open platform. The problem is we succeeded. So it was very open, maybe too open. And a lot of people started abusing the power we're giving the application. So we're going to go in details about some of the issues we've seen in the wild and why we're restricting access to some of the APIs.
All right. So why don't we switch places here? Awkwardly placed in front of the fern. So
between 2 ferns.
My co-speaker is a plant. All right, so in the M release, Marshmallow, various user improvements that we had. On the battery side, we had something that we call doze mode. So clearly, the users are usually using one thing at a time, right? There's one application running that's in the foreground. That's the thing that they really care about. And we kind of want to make sure that things in the background aren't doing too much and soaking battery when they shouldn't. Doze mode was the idea of predicting when the user wasn't even using the device at all, so we could sort of put a bunch of things to sleep. So if the phone is on battery, so it's not plugged in, and the screen is off and the phone is not moving, then why don't we stop doing stuff? So we would detect this, and then after a few minutes of this inactivity, then we would basically shut things down and then wake up for these sync points. So this allowed us to batch up the things that would then use the data connection, sort of spin up the antennas, pass messages back and forth, and then go back to sleep so that we could make battery last a lot longer.
And those checkpoints are very important because on the phone, doing something like waking up the radios and connecting to a cell tower or even a Wi-Fi network is extremely expensive in terms of battery. And so if we're not batching all those wake ups, we would be constantly like turning things on and off and draining the battery really quickly.
App standby is detecting things where the apps are not running. This is not the foreground app. This is not something the user cares about right now. So let's actually shut that down and not give it constant access to network activity in particular, which can be quite expensive. On the privacy side, this was the first major step that we'd taken that affected developers' lives very directly because it was basically a behavior change on the platform. We introduced something called runtime permissions. In an ideal world, this is how permissions would have worked from the beginning on Android. Instead, we had a system where the application would list in the manifest that they built with, at build time, they would say, here's all the permissions that I need. And then when the user would install an application from the Play Store, it would spit up a list and say, here's all the things the application needs. And then the user would just click OK, right? Like they don't have enough information to understand the context of what it's asking for. Maybe some of those things would look scary and they wouldn't install it, or maybe they just didn't understand and they would put it on anyway. We had the Uber driver on the way here was basically saying, I never pay attention to that stuff. I want the app and therefore I put it on. So we moved in the M release to forcing developers and applications to give the user more context, more information. So instead of just clicking on OK at install time, you can install the app, and then when the app first requires a particular permission, it is going to ask the user, and then the app has the chance to say, okay, I'm going to need the call log permission, and here is why I need that information. And then the user has enough information to make the right choice. Not only that, but they also have the ability to then go into settings and disable some of these permissions if they no longer want to share that information.
And another prime was that a lot of those permissions were grouped together. For instance, we had a permission called phone. And there's a lot of things that are covered by the phone permission. So for instance, if the app wanted to get the unique ID of the device or your phone number, for some registration, they would also have access to your call logs to know who called you and who you called. So this could be pretty scary for users. You see, why does this game need access to my entire phone information when really they were not doing anything bad, but it was a turn off for a lot of users. And same thing for the access, for instance, to the file system. When you requested access to the file system, you had access to everything, which is a little much.
So moving on to the N release, on the battery side, we continued improvements on Doze. We came out with something called Doze++ or Doze Lite, or other people just called it Doze, where we no longer required the phone to not be moving. Said actually, if the screen is off and it's on battery, then we can probably shut down a lot of this stuff to begin with. And then if the phone also stops moving, so for example, when my phone is in my pocket but I'm not using it, why don't we just stop all that background activity and network access already? But then when the phone stops moving, well, that's a deeper sleep mode and we can turn off even more. We also stopped applications from being able to wake up every time the user took a video or a picture. So from the beginning, you have this idea on Android of broadcast where when a particular event takes place, you can register for interest in that event. And it turns out that a lot of applications care about taking pictures on the phone, and then they would say, oh, well, I want to know when a picture is taken because maybe I want to use that for some of the information that my application requires. So what would happen is user would take a picture and every application on the phone would suddenly wake up and go, oh, do I care about this? No, I don't. But the problem is we can't fit all of those applications in memory at the same time. So they would all wake up one by one, and then the system would thrash, and they would all get killed one by one as everybody woke up just to say, no, actually, I don't care after all. So we shut that down. We no longer allow applications to register interest in either pictures or videos because, frankly, they did not need this information. They just kind of registered for it, well, just in case. But it was not worth the trade-off for the user and the battery. Connectivity broadcasts, same thing. Like everybody kind of cares when you change networks. Turns out not that important, and it would cause the system to thrash. right? So why not just make it a little bit harder for applications to automatically register for this thing that really puts the phone and the battery into a bad state?
And this kind of thrashing, if it happens while you're using the phone, suddenly everything would go slowly. So obviously that's a bad experience. But even if you're just listening to music, the phone is in your pocket or in your bag, if the system started thrashing, like Chet said, apps would start getting killed. And at some point, even your background music would get killed. So suddenly your music would stop, and that felt more like a bug on your phone than an actual correct behavior of the system.
So sanity check. Can the people in the back hear us right now? Is this loud enough? Excellent. All right, we'll keep going. Privacy. We started to look at, okay, well, what permissions are actually enabled on the folders and the files? Oh, this doesn't make sense. Let's make sure that, only applications that need access to these things should have access. So we started cranking back on permissions on those resources. In the O release, on the battery side, so from the beginning, Android has had this concept of wake lock. So we started out with the Linux OS for the kernel, which was great, but it didn't have facilities for wake lock. So the OS would see that there was inactivity and it would shut down completely, which meant you could be in the middle of a phone call or receiving a phone call and the phone wouldn't take it because it had just shut down. So the Android platform team added the capability called wake locks to make sure that you can register for interest in something and keep the phone from shutting down. If you're receiving a call, you set a wake lock and make sure that you can actually complete that action before allowing the phone to actually go into a deep sleep mode. So we've had that from the beginning. It's really powerful. However, applications can take a wake lock and then just forget to release it. Right? And this puts the phone in a bad state because now it's not going to go to sleep because it thinks something important and temporary is going to happen, but the application just forgot to release this resource. So we have this idea of cached applications, which are applications that are in the background. They haven't been used for a while. Frankly, they're right on the list to be killed next when the OS needs more memory and resources. So when they get into that state, we'll take away any wake locks that are held to make sure that the phone can actually go to sleep. We had made it very easy from the beginning to register. This is related to the photo and video stuff, to register for interest on these broadcasts. And you just put this in your build file, and now whenever any of these things happen, your application will be woken up to see if they want to do anything about it. That is no longer possible. You can't just register at build time. You can still get access to these at runtime. You can write code to say, this is something I actively need, but we don't make it as easy to fall into the trap of forcing the system to wake you up every single time one of these things happen. Background, we started limiting, and this is an ongoing theme, the amount of stuff that background applications could do. One of those things is creating a background service. If you're in the background, if you're not the foreground application that the user is using, then you cannot start a background service, right? It makes sense. This is not the thing that the user cares about right now, so we're going to limit the amount of things that you can do there. And we also don't allow you to get location information as often as you want. This turns out to be a really expensive operation. So if you're sitting there running in the background and constantly polling for a location, then you're using a battery that the user would actually like to reserve for something else on the system instead. On the privacy side, we started backing off of what you could do with non-resettable information about the device. So from the beginning, application vendors would use this for valid reasons like I want to make sure that this user has bought my application, and they would use the hardware ID of the device. Well, then that user took their device and they wiped it, reset it, gave it to somebody else, sold it, whatever. Maybe they share that device with someone else, and now the application has data information that is completely obsolete and out of date. Right? We need to be able to reset that information. We need to make sure that applications are not tracking information that just doesn't make sense in a world where we shouldn't be locked into the specific hardware ID. So we backed off to something called Android ID, which is resettable and is based more on user account and application information instead. Wi-Fi scanning info. It turns out if you have information about the Wi-Fi network, about the routers that you are connected to, or the routers that are in your particular area, you also indirectly have information about location, because there are databases out there where you can access this information, say, well, these routers actually exist in the real world in this location, and therefore indirectly, I know where the user is. Right? Well, that is information that the user has not chosen to share with you. So if you have access to Wi-Fi scanning information, you also need location permission so that you can be very transparent And the user knows, okay, since they need this information, I also need to be comfortable with them getting my location.
And you'll see this is also something pretty common. We try to reduce access to the background location for privacy reasons, but apps found many very creative ways to get access to the location, and this is just one of them.
You're going to see more as we go into other releases here. So in the P release, which is a year and a half ago.
Android 9.
Yes. On the battery side, app standby bucket. So we'd already started cranking back on some of the capabilities of applications that were running in the background. Now we got more specific about what we actually meant. So if there's a foreground activity, this is the application that the user is actually using. We don't restrict anything. Obviously, the user wants this application to be running right now. The application can do everything that it normally could. Working set is, well, they're not actively using it now, but they usually use this app at least once a day. So when they're not running as a foreground application, we restrict some of the activities, but most of them can still happen. Frequent applications, maybe they don't use it every day, but it is a common application that they do use. So again, sort of cranking back a little bit more and more. Rare, no, they don't use it very often, but they do actually use the application. Again, when they're not the foreground activity, make sure that they can't access these resources on a constant basis. And then there's the situation like, this reader app that I installed where, yeah, I installed it, but I never actually used it. And then it was running constantly in the background doing things that I didn't want it to, downloading new information, whatever it was. Like, why was it doing that? I never ran it. Well, why don't we just not allow that to happen at all? Yes, the user put it there, but then they forgot about it. They never run it. So why don't we stop using the resources on the phone for something that the user does not care about? We have something on Android called Battery Saver. It kicks in automatically, I think, when the battery hits 15%, or you can enable it constantly if you know that you're a high power user, as my kids are with some of the social media apps. They're constantly getting messages from that, and their battery drains quicker, whatever. They'll put it into Battery Saver at a much higher rate and then get more time. It turns out that our heuristics weren't very good there. We would disable animations, which made the user experience awful, but it didn't actually save that much power. What actually used a lot more power was access to network for background applications. So now when you put it into battery saver mode, again, we crank back significantly on the things that background applications can do because the user asked us to. Battery saving is really important, so just stop all this activity in the background so that I can keep the battery around for the things that I actually care about. We throttle Wi-Fi scanning, as I said before. A lot of these resources are really expensive with communications, with the data and antennas there. And also, if it's kind of a single pipe, right? If you're going to go, if your application is going to scan networks to sort of see what else is around there, you are using a single resource that other things are trying to use, right? Somebody's watching a cat video on YouTube, turns out that's actually using the same network resource, right? And that cat video was really important at that time. You don't want to make that hiccup just because a background application kicked in and wants to see what network routers are around there. So we throttle the amount of times that you can do this in any given hour to make sure that you're not consuming valuable resources that the user wants for their foreground applications. On the privacy side, again for Wi-Fi scanning and again for location, it turns out that these applications that would scan for information about network routers and where we are could again get information about locations. So now they actually need permission in order to do that. Also in the P release, also in privacy, background sensor access. You can no longer get access to sensors like microphone and camera if you're running in the background. Foreground application, that's great, but if you're running in the background, chances are the user doesn't really want you to have access to that.
We've seen applications in the past who wanted to keep running in the background so the app wouldn't get killed, so the next time you go in the app, like it starts quickly. And the way they would do that was either by recording sound in the background just so that they would stay active, or by just playing a white noise, so that noise that you couldn't hear, so that way the system thought the app was doing something and would keep it alive.
Probably really annoyed our dogs too.
Like I said, app developers can be very creative.
We got clearer about what information applications actually needed. So before you could access the phone, you could say, I need the phone permission, and that meant, actual phone, like the ability to access the phone, but it also gave you access to the call log. Well, that's user data, right? Let's make it clear, no. It's not just the phone and the phone app that I needed access to, but I actually want to read your contact information. So now there's a new permission that you have to register for, so the user can say, wait, I'm not comfortable with that permission, with sharing that information. Cell info, again, requires location. This is another one of those background ways where if you could get information about the cell hardware and state on the device, then you could also sort of connect the dots to information about location at the same time. So now, not only do you need permissions in order to do this, but the user needs to enable location permissions or location on the phone, right? If they've already set a setting on the phone saying, I don't want location services enabled, then applications shouldn't have access to location no matter how they get it. On the usability side, we started implementing something called non-SDK interfaces that were basically blocking access to private APIs. So APIs are really important. APIs are the public mechanism by which applications are written, right? This is the contract between applications and the platform. We have the following capabilities in the platform. APIs are the methods and functions that we expose those capabilities through, right? Well, we also have a lot of other methods that we don't expose. We have private APIs, and we also have something on Android, which is a clever workaround for a Java limitation called @hide. So they're public APIs so that we can use them internally between packages, but we @hide them, which means it's not in the SDK. It's not published in the SDK, it's not in the docs, and if you try to build against it, you will not be able to. However, Java has reflection, which means that you can at runtime say, oh, I know this API exists, so through reflection I will detect it, and then I'm just going to call it directly. That works great on that release, and then on the next release, we got rid of that method, and your application crashes. Right? Huge user problem because they don't care what APIs are being called. They only know that when they upgraded to the next release, your application crashed, and it crashed because you were doing something that we didn't anticipate on the platform team.
It can be a user problem or it can be an issue for us. There are changes we couldn't make to the platform because there were very popular apps out there that were using it, and you would not want to break an app that's used by 500 million people. So that was also making our own life harder. And then there's always the problem on Android of fragmentation across versions, but there's also all the different devices sold by very different manufacturers, and any private API is not guaranteed to be available on all those devices that are not ours, for instance. So the only APIs that are guaranteed to exist everywhere are the public APIs. And on Android, we have something called CTS. It's a very, very large suite of tests that tries to ensure that the behavior of the public APIs is the same across all those devices. The manufacturers have to pass those tests, and it's hard enough to cover everything. So if on top of that we have to worry about private APIs, well, yeah, it's not going to work.
So the changes that we started making in the P release were to make it not possible to call private APIs anymore. We're going to basically make that reflection call fail, or we're going to no-op the operation that calls that. But we don't just do it arbitrarily because we don't want to make these apps crash and make the user experience awful. So one by one, we're going through the methods and the fields and the classes that we know that applications are accessing, and we're either exposing those as public APIs and basically saying, yes, it's okay for you to call this now, or we are exposing new functionality so that we can say, well, this needs to remain private, but here's what you need to do instead. Then we shut down the private API so that we can do what we need to do in the platform, but we give applications the access that they need to the platform capabilities so that they can actually get by in future releases.
Or sometimes it's something you should not do,
Yeah.
and that will stop working.
Yes.
And that's it.
All right, Q release. This is the release that just came out. So this is the latest stuff. On the battery sides, turns out Wi-Fi enabling should be left up as a choice to the user. So applications had the ability to automatically enable this, probably for very valid reasons. They needed Wi-Fi to do a peer-to-peer connection or to see where the user was with respect to whatever it was, totally valid. However, you should leave that as a choice to the user to enable Wi-Fi. Maybe there's a valid reason why they didn't want it enabled. So now, if you want to enable Wi-Fi, you basically need to have the user change the setting. This used to be a painful thing because you would tell the user, well, you need to run settings, but how do you describe to the user how to get to settings on an arbitrary device and an arbitrary release out there? So now we have an inline way of accessing the Wi-Fi settings where you can create this intent and essentially launch the settings application inline in your application, bring up the UI directly. You can explain the context. I need Wi-Fi to do the following thing. Here's the UI. Please enable this thing. And this is not just for Wi-Fi, it's for 3 or 4 different settings as well. But basically, mechanisms to say, yep, we understand applications need this, and here's the way to use the system functionality to enable it, instead of allowing you to secretly enable it using APIs on the platform. On the privacy side, many changes. Scope storage. It used to be possible for applications on external storage, or they were using external storage to access data that was created by other applications, right? That's probably not what the user intended, right? So if you're using this application and it creates a photo file out there, why does this other application have access to it? It may be totally valid, but it needs to be a decision that the user is involved in. So now you can ask for access to this. You can say, I need access to the following, photos or videos or audio files. There's an API to do that, and it requires permissions so that the user can be involved. If you need access to arbitrary files, PDF files, whatever these things are out there, you really need to be using the system file picker instead. So there's a different API that'll launch the file picker, and again, the user is involved in that decision instead of your application just being able to rip through the directories on external storage and get access to anything that it wants. Photo location, again, location. It turns out that the metadata in photos on these amazing mobile devices has information about where the photo was taken. By default, it tends to record that. It's really useful. I think most of us like that. However, that means that if you can read a photo file, you can also get the metadata, and you can also find out where the user was. So this is a background way for applications to get access to location and historical location information that the user didn't know about, right? So now through the storage changes, we're making sure that when you get access to a photo file, unless you have permission to get location and unless the user is involved in that decision, then we strip the metadata, so you only get access to the photo file instead. And again, location from background apps. We now have a tri-state. It used to be possible for the user to say either, I want you to have location or I don't want you to have location permission. Now there's a tri-state where you can either deny it or you can accept it when it's running in the foreground, or you can accept it for running all the time. So even when that app is in the background, they could get location, but it needs to, again, be a decision by the user. More on the privacy sides, you can't find out information about how often we contact particular people in the context list. Another way of accessing this interesting information about location was through procnet. So you can no longer get access to the directory where we stored a bunch of sort of tedious details about network information. More changes to resettable IDs to make sure that you didn't have this non-resettable information for the devices. When you're using the clipboard, that information should only be accessed by the foreground app that the user is using as well as the keyboard that needs it. Camera data gave you really good information about a device, which was kind of a indirect way of getting information about the hardware that the user didn't necessarily want to share. So that requires a camera permission now. And some of the connectivity APIs now need access to find location. Again, involve the user in the decision, make sure that they're okay with this permission that these things have access to. And then finally, on the usability side, we continued working one by one through all these private APIs, figuring out how to make that information public or not, depending on what the use case was. And then finally, background activity starts. It used to be possible for you to run as an application in the background and then start another activity that would pop into the foreground. There's a couple of examples of why this is bad. So you could be running maps. You're navigating using maps. That's really useful. We like to do that thing. And then an ad pops up. The map pops out to a picture-in-picture, and we're not getting the navigation information that we need full screen. Instead, we're seeing an ad. Maybe the application likes that, but I doubt the user does. Here's an even scarier one where somebody was on a ride in a ride-sharing car, and the driver had a hard time getting there because this ad service kept popping up in the foreground. They couldn't even see their navigation information anymore. So we cranked back on that. It's no longer possible to launch those things from the background. And just in the last week alone, we blocked nearly 18 million ad pop-ups by background apps. All right, so on the battery side, we talked about a lot of stuff here. It's all about limiting the stuff that doesn't really need to happen, save the battery for the stuff that the user actually wants to be happening. On the privacy side, let's give users control over their own information and make it more transparent about what's actually going on with that information. And then finally, on the usability side, let's make the devices and the applications more predictable and usable in general. And now,
all right, let's move on to the developer stuff. I have to be pretty quick on some of it. How many of you are using the Kotlin programming language? She's very happy about it. All right. So historically on Android, the two programming languages that are blessed by the platform were the Java programming language and C++ for high performance stuff or porting games, for instance. But all of our APIs pretty much are available as Java APIs. And a couple of years ago, we decided to officially adopt the Kotlin programming language. So for those of you who don't know, it's a language that's designed by JetBrains, the company that makes IntelliJ, and Android Studio is built on top of IntelliJ, so there's already a strong relationship there between us and JetBrains. And it's a more modern language that offers a lot of extremely interesting features that we really, really like. And recently this year at Google I/O, 6 months ago, we announced that Android is going Kotlin first. That means that a lot of our efforts are going to be towards Kotlin more than the Java programming language. We are still supporting the Java programming language. The platform is still written in the Java programming language, but you're going to see more and more Kotlin. For instance, some of the Jetpack libraries that we're working on, some of them will be rewritten in Kotlin in their next versions. Kotlin is already used by a lot of apps on the Play Store. So here you have a list of some of the most famous ones. And we have Christina in the back from Pinterest. They use Kotlin heavily there. And Christina, for instance, was one of the members of the community that inspired us to adopt Kotlin officially, because we saw a lot of excitement from the community there. So yeah, 60% of the top 1,000 apps on Android are already using Kotlin, so it's definitely ready for production, and you should take a look at it if you're interested, and 53% of our pro developers. This year we also had a series of events called Kotlin Everywhere. I think they're still going on. So if you're interested in the Kotlin programming language and you'd like to learn about it, you can attend one of those events. They're all around the world, so chances are there might be one around where you live. One question we got a lot when we started talking about Kotlin is whether we are using it internally at Google. It was a difficult question to answer because Google is a large company and we have a system internally called Google 3. That's where all the code at Google lives. And everything in Google 3 is custom to Google. The build system, the file system, the versioning system, everything. Like we have web IDs, we have code review tools that are all internal to Google and specific to Google. So it took us a while to upgrade all that infrastructure to be able to support the Kotlin programming language. But we've made a lot of progress thanks to the hard work of many people at Google. And now there are Google apps on Android that are already using Kotlin. So we use it in production ourselves. So we have Google Drive, Google News, Sheets, Slides, the Nest application, and there are more coming. We are also, like I said, working closely with JetBrains. So Kotlin is a fairly recent language, and there are a lot of improvements that need to be made. So we're helping JetBrains there. We are working on making compilation faster. That it was one of the downsides of Kotlin. Some of the features in Kotlin might be a little slower to compile than before. But every time we ask the community like whether it mattered, they prefer taking these slowdowns in terms of build speed and gain the productivity that Kotlin offers. Annotation processing, because the language is more dynamic, it's more dynamically typed. There are a lot of features like extension functions. It makes the job of the IDE harder when we need to do code completion, refactorings. So there were some inefficiencies in the IDE. So again, JetBrains is working hard on that to fix them. And we have this tool called R8 on Android. R8 is an optimizer. It looks, once you've built the entire application, R8 can look at the entire application and perform a ton of optimizations. Many of those optimizations are about shrinking the size of the app, getting rid of all the APIs you don't need, if you have function calls that you created but you never use. It's very useful when you use third-party libraries because you might not use the entire library. So R8 is our way to fix that. And Kotlin, the compiler, like I said, it's a fairly recent language. So sometimes what the Kotlin compiler outputs is not the most efficient. So thanks to R8, we can re-optimize the program after the fact. And we're going to keep working on this. If you want to try Kotlin, there's this new web app called Kotlin Playground by JetBrains. You can basically write a small Kotlin application right there in your web browser, and you can just compile it and run it. So it's a very good way to get familiar with Kotlin. This is also something I use myself. Sometimes when I don't remember a particular syntax, I just want to test an algorithm. I just run it in the Kotlin Playground. It's easier than creating a new project in my IDE or compiling by hand. If you want to learn, if you're really interested in Kotlin and want to learn more, so we are partnering with Udacity. We have several courses on Kotlin and Android, and there's a new one on advanced Android. We also have an Android developer certification specific to Kotlin on Udacity. So that class costs $100 and $149. For the next 3 months, you can get it for $99. If you go on Twitter, if you find the Android Dev Twitter account, they post codes that you can use to get it for cheaper. Right, now on to Android Jetpack. So Jetpack is so one of the problems we've had on Android is we have a lot of features in the platform, but not the entire ecosystem does not update to the latest version of the platform at the same time. So it can be difficult for application developers to use the latest and greatest APIs because they're only going to be available on like 10, 20%, 30%, whatever it is of the devices. So a few years ago, we decided to start creating libraries to help with that. The idea there was to build, abstractions that will take care of handling the multiple versions of the system for you. Once we had that, we figured that we could go beyond that. So now we have libraries that offers new features that are not available in the platform. So we can update those libraries more often. You can adopt them at your own pace. That also means we can change the APIs because we're not going to break you. If we change the platform APIs, we're going to break the app without your involvement. But if we change the APIs in a library, it's up to you to upgrade to that library. At least you can decide when you do that. So Jetpack is used by most of the applications on Play Store. And we now cover, I'm not going to go through the entire list, but we have over 70 different libraries that cover pretty much everything you can think of. So like I mentioned, there's compatibility. We have UI widgets, for instance, the view pagers or the recycler views. We have a CameraX library that's meant to help you use the camera APIs. We have Kotlin extensions, so if you use Kotlin, we have extra APIs that makes it even easier to use our Android APIs with Kotlin, and there's more coming every day. So my team at Google works on a lot of those libraries, but we also partner with other teams at Google that write their own their own Jetpack libraries. So for instance, the security team has their library. There's also one for biometrics, so if you want to do like a face unlock or use the fingerprint sensor, we have a library in Jetpack to make this easy. Over the past few months, here's what we've done in Jetpack. So at I/O, we announced a library called benchmarking. It helps you profile your application. Profiling on a phone is very difficult to do right, mostly because phones use thermal throttling. So if you run something really fast on the CPU and use a lot of CPU, the device will start heating up. And to avoid, burning the user's fingers or draining the battery too fast or even melting the device, we lower the frequencies after some point when the device starts getting hot. And that affects performance on your application. So when you do profiling, you have to take that into account. There are ways you can prevent that from happening, but you need to know exactly what to do. So the benchmarking libraries do some of this for you. There's also documentation and hints and links that help you do it right. We also use it in CI in Jetpack to measure performance improvements and regressions of several libraries. So this is an example, a screenshot of one of our dashboards that we automatically generate. And we have articles out there. There were talks at Google I/O at the Android Dev Summit this week where we explain how you can integrate benchmarking in CI so you know exactly when you make a change, if it causes a performance regression, you know exactly where to look. And that library is available as a release candidate. It's almost 1.0. View binding, so for the Android developers out there, the way you define a UI in Android is you have an XML file, and then from your code you need to call this function called findViewById, where you ask the system, hey, give me a reference to the view that has this name. It's a little cumbersome, it's error prone, so we have a new library called view binding that will do all that work at compile time in a type-safe manner. And it's available in Android Studio 3.6. So if you want to get started with Android development, you should definitely use that library right away. CameraX, I mentioned it quickly. It's going to hit beta in December. Again, there's many devices in the Android ecosystem behave quite differently sometimes. So the CameraX library addresses those differences and implements workarounds for known issues. We use it ourselves in a couple of Google apps in production, and we've seen a 10% reduction in crashes related to cameras. So if you're about to write an application that uses the camera, definitely go take a look at this API. All right, then I want to talk about Jetpack Compose. Can you show me if you've heard of Jetpack Compose? Well, Christina, you don't count. Okay, so Jetpack Compose is our new UI toolkit. It was inspired by the declarative and reactive frameworks out there, so things like React Native or Flutter or React.js. And we think it's a much better way, a much easier way to build Android UI. So this is something that we open sourced at Google I/O. It's not ready for production yet. And a couple of days ago, we released our first developer preview. that you can access by downloading Android Studio 4.0 Canary 1. And it's a Canary build, so things might be broken, and probably are broken. But let's go through what Jetpack Compose is. So according to our own documentation, it's a modern toolkit for building native Android UIs. It simplifies and accelerates UI development on Android with less code, powerful tools, and intuitive Kotlin APIs. So that's not very helpful to you. The main point here is that it's written in Kotlin. So when I said we're going Kotlin first, this is the kind of stuff we mean. So our next UI toolkit that we hope will last us for the next at least 10 years is written in Kotlin and not in Java. I gave a talk with a couple coworkers at Google I/O where we went into a lot of details about why we're building Jetpack Compose, but I want to give you a small summary here. So the main thing we wanted to do was to simplify the development experience. And to show you what I mean, we're going to go through a very simple example. So this is a very simple app where you have a text field at the top, you can type something, and then you have a list of contacts, and we just want to filter the list based on what you typed. So the way you would do it with the existing UI toolkit, you would first write an XML file that contains the UI for this main screen, so the text field and the list underneath. That's a lot of XML. Then you need another XML file that describes the layout of each list item. Then you need to write here it's a Kotlin file, could be a Java file, where you inflate those XML layout files, where you find the views, you set them up, so you set your listeners, you set your adapters, all that manual wiring you have to do. Then you need to implement the filtering code. It's a lot of code. And finally, you're done. With Jetpack Compose, the entire process looks like this. That's all you need. The point of Jetpack Compose, for those of you who haven't used those reactive frameworks, is that you effectively declare what you want the UI to look like. So if we go quickly through this, so here at the top we have fun. In Kotlin, that's a function. It's just a top-level function. So with Compose, a component or widget is a function. That's all it is. It's not a class anymore. It's just a function. And it's marked with this @composable annotation. And then here I have my UI. I have a vertical scroller, so I just want a vertically scrolling list. I have a column. It's kind of like if you want to stack the widgets vertically. Then I have my text field. That's where the user can input the text they want to look for. And then I need to build that list. And the way you do that in Compose, you take your list of contacts and you can just iterate over that list of contacts, and for each iteration I say I want a row with an image and text, and that's it. There's no like finding views, trying to create them from XML, setting listeners and all that stuff. And what Compose will do for you is that every time the list of contact changes, this will get re-emitted, this will get re-executed automatically, and the UI will update. You don't have to set listeners, you don't have to do anything. So the powerful thing for you is that all you have to worry is your data model. We saw a lot of sources of bugs in Android applications where you have your data model and then you somehow have to connect it to the views, to the UI, but the UI widgets have their own data model. So you have to set listeners both ways to try to keep those two models in sync, and pretty much 99% of the bugs related to the UIs in Android apps are because of a lack of synchronization between the two models. So in this case, the only model that exists is your model. It's the list of contact. The views themselves don't have any state. You provide the state always. So we also wanted to fix what's broken. We have a lot of regrets about our APIs. There are things we could have done better, so this is our chance to fix them. We want to stop cheating. Chet mentioned that we have a lot of private APIs that we use heavily, and we think that's unfair to you because there are things that we can do in the platform, and if you want to recreate them or improve them, you cannot. So all the widgets that we're creating for Jetpack Compose are built entirely on public APIs. So if, for instance, well, actually, I just showed you this vertical scroller. There was a small bug in the version I was using. So the way I fixed it is I grabbed the source code from the source tree, I copy-pasted it in my app, I fixed the bug, and it worked because it does not rely on any private API. So I was able to do that. And we want you to be able to do the same. Mature design is the way our UIs are built on Android today. That did not exist when we created Android, so we had to put mature design on top of the existing UI toolkit. That led to a lot of awkwardness, and we had to deprecate APIs, and it's not ideal. So Jetpack Compose is designed so mature design widgets are just a layer. So if there's ever another mature design, will be set up for success. We are also designing Compose in close relationship with the tools team, and I'm going to show you a quick demo of what I mean. And finally, yeah, Kotlin, we already talked about that. Compatibility with the existing UI toolkit is very important. One of the things we love about Kotlin is that it's fully interoperable with the Java programming language. So if you want to switch to Kotlin, you don't have to rewrite your app from scratch. The next class that you add or the next file you add to your project can be in Kotlin, and you can have Kotlin and Java in the same project, and they can talk to each other without, it's not like you have to write JNI, for instance, with native code. It's very seamless. So we want the same thing for Jetpack Compose. You will be able to use the existing views inside Compose, and you'll be able to put Compose inside existing apps. So when you're ready to adopt Compose, maybe the next screen in your app can be written in Compose. You don't have to rewrite anything that's already there. This is the tech stack for Compose. The main interesting point is that Compose is implemented as a compiler plugin. So a lot of the optimizations and a lot of the things that make Compose reactive and declarative is typically done at runtime in this kind of frameworks. We're doing most of the work at compile time. We think it will lead to more efficient applications. So that's material design. So we have to go a little faster. So quick introduction to writing Compose code. So like I said, a component is just a function. We wanted to make it very easy for you to create new widgets. So you write a function, you mark it at composable. The state or the data for your component is just the parameters of the function. So here we have an example. It's called greeting. I pass a string, and I want to emit the UI. A good comparison for how it works is if you replace text with a system.out.println, you're emitting something in the console. So this is the same idea. You are emitting a UI. And if I invoke greeting with different parameters, it will of course update. So hello world. If I change, I got hello droid.con. And let's switch to a demo. Sorry. All right. So this is a simple app I wanted to write, and of course I broke the emulator. I'm gonna restart the emulator real quick. Should be fast. Okay. So this is a small app I wanted to write. It's just a photo gallery. I want a list of some of the photos I've taken. So right now you can see it's pretty empty. And this is the implementation of the app. So we can ignore this bit here. You can see here that I wrote a component. You want bigger? Okay. All right, big enough?
Yeah.
All right, cool. So I wrote this component called a photo card. It takes a photo as a parameter. So photo is just a class I created that has a title, a description, and an image. And then I just built, something that looks like a material design card with the picture and the two pieces of text. So now what I need to do is create a list of those photo cards to display all my photos. But before I do this, I want to make sure that my photo card component works well. And we have a new feature in the IDE to do this without running the app or building the app. So here what I did is I just created a new component that's called preview photo card. I created some test data. So I have this photo object. Then I'm going to set a material theme to make sure that I have the right colors. And then I will invoke my photo card and give it the test data I just created. And when I hit build and refresh right here, Android Studio will build a project. I missed something. That's not going to work. I need this preview annotation. So if you add this extra annotation, the preview annotation, Android Studio, here you go. We'll build a project, find the preview components, and display them right here in the IDE. So this is not running in the emulator. It's not running on Android. We're just running the Compose code directly in the emulator. In the IDE. And the really powerful thing is that you can create as many previews as you want. So if I copy paste this, give it a different name, I change the colors to a dark theme because those things are very popular these days. I can just refresh the preview, and I'm gonna see my two previews with two different themes for my card. And of course, I could change, the test data and use it in different situations. But so now that my card is working, I can write the app. So again, I'm going to use a vertical scroller to see my list of photos. I'm going to create a column to stack them. I'm going to add some spacing around to make it look pretty. And then I just need to iterate over my photos. So it's just a for each on the collection of photos. And for each photo, I instantiate a photo card and add some space underneath. And that's it. Now I can just run it. And in the emulator, there we go. We have a working list of photos, and that's all you have to do. So again, compared to having to create, all those XML layout files, inflating them, creating each row one by one, finding the views, calling the setters, this is so much easier. And not only that, but it's easier to maintain as well because you can clearly see the intent of the developer who wrote that code. Okay, we have 5 more minutes, so we're gonna try to go quickly through the rest. So if you're interested in Compose, you can go to d.android.com/jetpackcompose. We have a ton of information there, or you can just go to d.android.com, that's our developer website. Give you time to write that down.
Android spelled A. And
we have a tutorial that will show you how to build something very similar to the demo I just showed you. We have sample apps. Like I said, you can download Android Studio 4.0 Canary 1 and start playing with Jetpack Compose. The way you do this is super easy. When you create a new project, you can choose a template, and we have a new template for Compose that will set up the project the way it needs to be set up so you can get started in just a few seconds. We have the previews. We talked about this. We have sample apps. You can find them. I think they're referenced on the website, or you can find them in the source tree of Compose. That gives you an idea of the kind of things we can do today. Again, Compose is not ready. This is not a V1. It's not even an alpha. But this gives you an idea of what you can already do when you play with it. So speaking of Android Studio, won't have time for demos. There are some really cool stuff coming in Android Studio. For instance, we have a motion editor where you can create animations visually inside the visual editor for the layout files. So you can get timelines, you can change properties, you can preview all the animations right there in the IDE. You don't have to run your app. It makes it a lot easier to work with UI designers, for instance. If you're interested, there were talks at the Android Developer Summit showing a ton of demos for this tool.
those are all posted online on YouTube right now.
One of the big things we did with Android Studio this year was we spent many years adding features, and then we realized that adding features was great, but we added also a ton of code, and it was not always the fastest. So the team spent almost a year working only on quality and performance, and they had like really good results. So we fixed a ton of memory links. We fixed UI hangs, like you're using the IDE and like everything stops. So this is something that now the team is committed to making sure it doesn't regress anymore. Thank you, Chet.
Always working on build speed because it's
right. So
necessary.
The team working on the Gradle build system on Android has had a hard time over the years because they were making performance improvements, but the problem is that we're all paid to write code, and what happens when you write code, there is more code, and when there is more code, things build more slowly. And you can see here the graph. So this graph shows you the build speed of a particular app over time using different versions of Android Studio. So you can see that it kept going up. And finally, for Android Studio 3.5, the team decided that they wanted to do something more drastic. So they did a lot of things across the board, and we see a reduction of 20% in build times. So if you're already using Android Studio and you upgrade to 3.5 or later, you should see a build speed improvement in your app. And the team is, of course, still working on that. More importantly, Gradle is awesome, but it's also very flexible. So there's a lot of Gradle plugins that come with libraries or different tools and features that are super useful. But some of those plugins may be the cause of slow build speeds. So we have this new feature called Build Attribution. We will show you what takes time in your build, so you can go blame the right person if your build is too slow. And if we are the responsible, please let us know. So yeah, again, go download Android Studio 4.0 Canary 1. You can go on d.android.com and just click on Android Studio. You'll find the link, or you can use this URL right here. Yeah, and you'll get a lot of cool features. Do we have time for just one quick demo? Just go away. I'll do one quick demo. Okay.
I cede my time
All right.
to the other
Really,
presenter.
really quick. I want to show you the motion editor. It's really cool. Right. My demo is right here. Oh no, wrong one. Yeah, sorry. I'm using weird versions of Android Studio. You can see they're called Android Studio 0.0. They're just builds that they're ancestors of Android Studio 4.0. So hopefully it will work. This one. All right, go. Almost there. All right. So this is loading the project. Oh my God. It's indexing my SDK for some reason, because of course that's what happens when you give a demo. Right.
Sometimes you're building code, sometimes you're building anticipation.
You'd better like what I have to show you, or I will feel very bad about it. All right, go away warnings.
If only the build were faster.
So okay, we're on stage. We can keep going. Okay, so this is our visual editor. This is the motion editor. So here you have a layout for the application. So you can position the widgets, you can move them wherever you want. But here you can see that we have two states for this layout. We have start and end. So we have this card that can expand at the bottom. And all you have to do to create those two states is to just change the layout in the editor. And then when you create a transition from start to end, that's this arrow here, if you click on the arrow, you can then access the timeline and you can preview the animation right here in the IDE, so you don't, again, have to run the app. And of course, you can create as many states as you want. You can change colors, you can change alpha, position, size, whatever it is you want.
Customize the animation as well.
Yep. And time for another quick demo? Okay.
How to give the organizers a heart
this one is fast.
Is this layout editor?
No, that's layout inspector.
Yeah.
All right. So I have to resize this window. Okay. Build system is doing something. All right. So I'm gonna run this test app. The app itself is not that interesting. What's interesting is this thing called the layout inspector. So in a couple seconds. Okay, that didn't work. So it's basically the equivalent of the Chrome inspector tools for websites, where you can see the tree of the app, like all the widgets, but you also see a live rendering of the app, and you can select the different widgets on screen, and it will show you, like, what files have contributed to which parts of the UI. So sorry it didn't work, but that's demos for you. And with that, we're finally done.